Today I'll talk about mathematical basis of k nearest neighbor. It is part of my series of lectures on machine learning. K nearest neighbor, or in short kNN, can be used for a classification problem or a regression problem, or can be used for outlier detection. This is the figure I have taken from this source to explain the concept of k nearest neighbor. This is a classification problem. Uh, K stands for number of neighbors. If we assess three neighbors uh, surrounding the new example or a new sample or a new data or a new point, then the classification class assigned to the new example or a new point is the majority class of the neighbors, the number of neighbors specified by the K. So if K is set to 3, there are three neighbors, two are green points and one is red point. So the new classification is assigned as the green point or a class B. If we set k is equal to 1, k is hyperparameter in case of k nearest neighbor. If we set k is equal to 7, it means that we need to assess the 7 nearest neighbors to the new example. So in when we set k is equal to 7, the uh, majority may change. So this is the basic concept behind k nearest neighbor. So the basis is on the basis of distance metric or any other metrics that I will describe later. So on the basis of distance metric, k nearest neighbors are identified. So nearest neighbors are identified on the basis of commonly on the basis of distance metric or some other metric. So category of new point is identified on the basis of majority class of its neighbors, as I have described in this picture. And the metric which can be used include these distance matrices like Euclidean distance or Manhattan distance. There may be other matrices like Hamming distance for text classification or Pearson and Spearman correlation coefficient. These are other metric which can be used to identify the nearest neighbors. So let us see what is Euclidean distance. So if there are two features, namely x1 and x2, so let us say graphically if there are two features, x1 on this x-axis and x2 along y-axis, then the distance between 2 points, if let us say these are the 2 points and we want to identify this distance. So distance is equal to square root of difference between this and this on first feature square plus difference of this and this, that is of second feature square. So this is the Euclidean distance or this is this distance. It is based on the basis of Pythagoras theorem. So this is the generalization of the Euclidean distance. So if x belong to a real number in a d-dimensional space, so dimensions may be more than 2, and yi is either 0 or 1. So distance between xj, xi and xj is written as this, and it is the summation of, so this distance square is summation of k is equal to 1 to d and square of this difference. So this is S stand for summation. And if you square root the entire term, then we get the distance. What is Manhattan distance? So if there are two features, namely x1 and x2 like this, then the distance between 2 points is given by distance is equal to the absolute of difference between these two plus absolute of difference between these two. So it is actually this distance from this point to this point and then from this point to this point. So Manhattan distance is used when there is high dimensionality in data. This is important to understand. So after the neighbors are identified on the basis of either distance metric or some other metric, then the majority voting is done to assign a class to a new class, new example or a new data. So if D is set of all points and nk x are the k nearest neighbors of x point, then if probability y such that there is x and d are all set of points. This is not the conditional probability. This is the writing convention. So the probability is equal to fraction of points in the neighbor of a particular class. So the prediction of the new example, that is prediction of y, is the argument max of y when we get this probability, that is a fraction. So this is about majority voting mathematically. Now, what are the inherent problems in k nearest neighbor? So if there is a highly imbalanced data set, then uh, the majority voting will point towards the most common class of the data set. So there is a problem. So if the other problem is when there are presence of outliers, and the third is curse of dimensionality. As I've told you that if there is high dimension data, then Manhattan distance should be preferred. And the other problem is the class outlier. So what is class outlier? A training example surrounded by examples of other classes is called a class outlier. For that, we can use kNN or the Hart algorithm. So this is all for today. Thank you very much.